Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and we'll go over the correct answers. So for this factoring, it's going to factor as an x squared minus 4x minus 5 would factor. So it's going to be x minus 5 times x plus 1. But since we have an x to the fourth and an x squared, it's actually going to be x squared minus 5 times x squared plus 1. And so that would be your answer for your factoring. For the math knowledge question, we have the sale price of a coat with a regular price of $84. And it tells us that the sale, all coats are 3/4 off the regular price. Well, if the regular price is $84, you're basically going to be paying a fourth of that, which is $21. B is your answer. Okay, so we are looking at lesson 101 today. We are looking at 3x3 determinants. Now we have looked at 2x2 determinants. You remember, if you have your determinant, you do A times D minus B times C, and you get your number there. It said the warm waters of the Caribbean, those are positive, and then the cold North Atlantic, maybe, if you look back in the book, or I don't remember exactly what it was, but it had that little picture with the positive and the negatives. But that's using a 2x2 determinant. But now we're going to be looking at 3x3 determinants. So hopefully you'll understand 3x3 determinants after this lesson. So I want you to write this down, and y'all may need to pause the video. But we have a 3x3 equation there. It's a system of 3 variables, x, y, and z, with 3 equations. Okay? It is going to turn into that if you use your Cramer's rule like we learned for a 2x2. And so remember that your denominator is all of the coefficients of your x, y, and z's. So that's where the a1s and the b's and the c's, they all go down here. And then if we are solving for x, instead of our a values, we put what our k values are. And then the b and the c's stay in the same spot. Okay? Now if we were solving for y, your denominator part would be the same as that denominator, and your numerator, you would have A1, A2, A3, and you would have a C1, C2, and C3, but instead of that middle column being your B's, you would have K1, K2, and K3. So that's how you would set up the determinant if you were trying to solve equations like this. So now what we're going to use, we're going to have to figure out how do we actually simplify those, okay? So we're going to use Cramer's rule to solve for x, y, and z. Now typically on these, it's just going to have you solve for one variable, but on this example, we're practicing Cramer's rule with 3x3 determinants, so that's why it has you solve for all 3. So this is typically only going to ask you for one variable. So we're going to start off by setting up our determinants, by setting up our matrices. So our denominator matrix is going to be 2, 1, 3, 1, 1, negative 1, 2, negative 1, and 2. Okay? So that's going to be your denominator. Now for your numerator, instead of your x values, you're going to put your constants that it equaled. And then the other 2 columns stay the exact same. So that is your setup for using Cramer's rule. And so now from here, what you're going to do, you are going to take the first 2 columns here and here, and you're going to write them duplicated right after your third column. So I just copied my 2, my 7, negative 2, 16, 1, 1, negative 1, and I'm going to do the same thing in the denominator. And so now, the way that you do Kramer's rule here, you are going to multiply these three numbers together, and then you're going to multiply these three numbers together, and then you're going to multiply these three numbers together. It's your diagonals, and you don't use those other three numbers that are to the left and to the right of those. Okay, so those first three numbers multiplied together is 14, and then we have negative 16, and then we have a positive 4. Okay, so that would be for your first part. Now you have to go back, and you have to go from the bottom left to the top right. And you're always using the diagonals that have three numbers. So you're going to multiply those three together, which is going to be a 32. Then you're going to multiply these three numbers together, which is going to be a 7. And then you're going to multiply these together, and there is a negative right here on that 2, so that's a negative 4. And now, just like you did with your 2 by 2, you did the first number minus the second number. Well, now we have 3 minus the other 3. Okay? So that would be for your numerator. And then we have to do the same thing for our denominator. Okay, so we're going to have 2, 1, and 2, which is going to be 4. 1, negative 1, and 3, which is going to be a negative 3. And then 2, 1, and negative 1, which is negative 2. And then you're going to subtract, and we're going to go the other direction. So we're going to have 3, 1, and 2, which is 6. Negative 1, and 2, which is 2. And then 2, 1, and 1, which is 2. And then you're just going to add and subtract your numbers. So 14 minus 16 plus 4 is a 2. 32 plus 7 minus 4 is going to be a negative, we have 35 here. And then over 4 minus 3 minus 2 is negative 1. And then we have minus 6 plus 4 plus 4, 6 plus 2 plus 2. 6 plus 4 is 10. So we end up with negative 33 over negative 11, which means that our x value is 3. Okay? So that's how you would do a 3 by 3 matrix. So now we're going to solve for our y. We're going to solve for our y. The bottom part is the exact same. And so I got a negative 11, so there's no reason for us to rework it if you know that you got your number correct. We can just use that negative 11 that we already had. And then, coming back up here, I'm going to keep my x's, so it's going to be 2, 1, 3. Instead of the y's, it's going to be 7, negative 2, 16. And then the z values is 2, negative 1, and 2. Okay, so that's how you're going to set that up. And then you're going to duplicate your first two columns. And I'm actually going to pull this down so that it's not quite so close to the x part. So we have 2, 1, 3, and then 7, negative 2, and 16. So now we know that our denominator is negative 11. 2 times negative 2 times 2 is negative 8. 7 times negative 1 times 3 is negative 21. 2 times 1 times 16 is 32. And then we subtract. 3 times negative 2 times 2 would be negative 12. 16 times negative 1 times 2, negative 32. And then these three would give you a positive 14. Okay? So negative 8 minus 21 plus 32 is going to be 3. And then we have minus negative 12 minus 32 plus 14. That would give you a negative 30, which turns into a positive 30. So I have 33 over negative 11. So my y value is negative 3. Okay? So that's how you would solve for your y. Now for the z. I'm going to write it, and then I'm going to move it down to the bottom. We're going to have negative 11 for our denominator. Our numerator is going to be 2, 1, 3, 1, 1, negative 1. And then instead of our z coefficients, we're going to use 7, negative 2, and 16. So I'm going to move this down here so that I can continue working it. And so we're going to take our first two columns and rewrite them. And then we're going to multiply here. So we'll have 32, negative 6, and negative 7, and then minus 21, 4, and 16. All over negative 11. And so 32 minus 6 minus 7 gives you 19. And then 21 plus 4 plus 16 gives you 41. So if you, over negative 11, so if you do 19 minus 41, you get negative 22 over negative 11. Our z value would be 2. And so that would be your x, your y, and your z value. Okay? So that's how you use Kramer's rule on a 3 by 3. So let's look at Kramer's rule to solve for z here. So we want to only solve for z. That's usually what they're going to do, have you solve for one variable. But if you look, we've got a little bit of a trouble because we don't have all three variables in all three equations. What I like to do is write my equations where I have all of my variables. And so I have 0x for the second one. And then I have 0z for the third one. Some of y'all may be able to do it without that, but I like it because it helps me line up my x, y's, and z's. So if I'm solving for z, I'm going to have, for my denominator, 3, 0, 1, 2, 2, 2, and then 1, 3, and 0. For my numerator, I'm going to have 3, 0, 1, 2, 2, 2, and then instead of my z values, I'm going to have 9, 14, and 3. So I duplicate the first two columns, and now we're going to use the exact same method that we did on the previous one. Multiply these three to get 18 plus 28 plus 0, and then minus 18. 28 times 3 would give you 84, and then 0. And then in our denominator, we'll have 0 plus 6 plus 0, and then we'll have 2 plus 18 and plus 0 from these three. So 18 plus 28 is going to be 46, and then 18 plus 84 is 102, so we have 46 minus 102, and then I have 6 minus 20. So 46 minus 102 is negative 56, and 6 minus 20 is negative 14. So if you divide those, your z value is going to equal 4. And so that's how you use Kramer's rule for a 3 by 3. And you can expand that to a 4 by 4. We're not going to do that this year, but you would use the same concept to do a 4 by 4. Okay? So on your homework, you do get to omit 3, number 1, 11, and 12. So make sure that you do that tonight so that we can go over any questions that you have tomorrow.